Okay, the problem statement is longest common suffix queries. Okay, so what is given? Two arrays of string given, words and words of containers and words of queries given. So each words of query you need to find for each, like say this is words of query, words query, and each for each word query, each word you have to find the string with a words of container which has a longest common suffix. Okay, so this is CD. This CD that is longest common suffix. This one CD, this one CD, and this one CD. So it has a you have to find any of the string, any of the word present in the word container. It has the longest for this one. You have to find for which string in present in the word container has the longest suffix. Okay, so now there are some ties. If you can see there are, this city is common, this city is common, this city is common. So in that case, if something is common, what you have to do? So that is given if there are two more strings in what container that share the longest common suffix. Here for this city, longest common suffix is city. It is sharing this longest common suffix with all of the words. If that is the case, we have to find the smallest in the length. So for this city, what will be the answer? You can see this one, like because this case CD is the length of 3, rest of the length of 4, so we will check the this one. Okay, so that is the case. And for let's say what is the answer for this PBCD? PBCD will be, what is the longest common suffix will be BCD, this BCD and this BCD. So again there is a type, like this BCD is common, sharing by both cases BCD and BCD, and length is also same. If length is also same, so here if two or more such strings have the same smallest length, then answer will be find the one occurred earlier, like what is the appeared first. This BCD is present first, so for longest common series we have to take this one. So to return an array integer answer where answer I is the small is the index of the string in the container. That means this CD, what is the answer for this CD, like what is the which word we have chosen for this CD, for the case CD, what is the index of this is 1. So 0 1 2, so answer will be length of word of query. For CD, what is the answer? 1 is the answer. Like which word we have chosen, or we can say uh, from that words of the word container, which index position word is having the maximum common longest suffix, sorry, longest common suffix with the query word query of ith place. So that we have to find it out. So we have to say like for this one, from which word this word has the longest common suffix. So that's why I have taken one. For PBCD, which is the longest common suffix, BCD, it is present in two cases. If it is the same, then I have to choose the first one. So this is how we can, for the answer will be 0 2, sorry 0, yes. And what will be the case of what will you call of XYZ? See, yes, Z is not present. Z is not present in any other any places. So in that case, suffix will be an empty string. An empty string can present in any places. Empty string can present any places. So every string has one common suffix that is nothing but empty string. Empty string. So what is the suffix of XYZ? Suffix is empty string. Empty string. Another one is Z, another is YZ, and another is XYZ. These are the suffixes. So if nothing is common, empty string is common for each and every cases. So in that case, so what I will do? So where it present empty string. So as I said, like empty string is common in all the cases, then it will be kind of length 0. And what will be the case of this case? If something has more common, so you have to choose the longest common with the string with the smallest length. So answer will be case CD, because its length is only 1. Sorry, length is 3. That is the smallest number among all the words present in the word container. So answer will be 1. Okay, this is the case. So let's see the constants as well. First is length will be 10 to the power 4, and length of uh, one single word present in the word present in the word containers could be the length of 5 into 10 to the power 3. What could present in the word query also is 5 into 10 to the power 3. Okay, it is only lowercase English letter, so it is fine. See, another constant is given. Even though length is 10 to the power 4 and the word present in that query or container doesn't matter. One single word can having a maximum length of 5 into 10 to the power 3. So in that case, if I consider that each maximum case is 10 to the power 4, so in each every case, what could be the maximum case? Uh, maximum character could present. So one word could present one in one word. 10 to the 5 into 10 to the power 3 kind of characters may present in one word. Okay, so maximum number of words is 10 to the power 4. So what could be the case? In that case, it will be 5 into 10 to the power 7. But the given here, the sum of words of sum of words container I dot length. That means if you summation do the summation of all the characters present in the all the characters present in each and word. If you sum those character counts, then it will be at most 5 into 10 to the power 5. That means what? It is not you are getting it was 5 into 10 to the power 7, but in the question it is given it is maximum that in the uh, whole array list or vector how many like total number of characters will be that is nothing but total number of character. What is meaning by sum of one? What is the length of here character is 4, here length is 3, here length is 4. So this is sum of all the characters present in the sum of all the characters actually that will be 10 actually for sorry 11 4 7 plus 4 11. That is meaning, so that is the meaning of that sum of container I dot length. That means in the simple words, sum of the total number of counts, total number of characters, total number of characters written in the whole array. That will be nothing but 5 into 10 to the power 7. We are getting from this two constant, it should be this one, but from this it is specifically mentioned it will be 5 into 10 to the power 5. That is the set. Okay. Okay, then let's see how could we solve the problem. Okay. So that means why it is given. We have an idea like if it is the case, we have to iterate that many times. So it could be even if you do big of n time, it could go out of index. It could go sorry TL. It could give us TL. So that means what? So anyhow you have to iterate each and every letter to somehow to compare or do anything. So that means even if we iterate only once of each character of the words present in the word container or word query. So it could be this. So this is just for only one. Assume like it is word of container plus word of length. So it will be into two. So this is for only one, and both could be this length, and this is for only one. Both could be this size, same size. Like so, if both are the same maximum, if it is a at most case, most possible cases, at that time it will be into two because there are two cases. One is what container, and what is one what query. Hope you are getting it. And in this case, it will be 5 into 10 to the power 5 into 2. So that means if you just normally iterate, so time complexity is 5 into 5 into is nothing but 10 into 10 to the power 7. This is nothing but 10 into 10 to the power 8. If you simplify this case, and here 5 into 2 10, 10 into 10 to the power 5, it is nothing but 10 into 10 to the power 6. So this is how you can understand. You can simply calculate like even if you single do the big of n kind of your solution is 10 to the power 8. So it will go, it can hit TLE, but it will be 10 to the power 6. That's why they have explicitly mentioned these constants. Hope you got the understanding. Okay. Okay. Now let's focus on how to solve the problem. Okay. So how to solve the problem? Let's say I'm pasting this thing. Okay, not here. It is not copied. Taking the same example, and let's try to solve the problem. Okay. So what could your primary instinct could say? First, obviously, brute force approach. Brute force approach. What could you say? Like we are taking this word and taking each pair, and each pair we are going to compare this to this two. Then taking this pair and taking this pair, when I can compare this to this two. This is how we could say it's a brute force approach. But obviously, it's a hard play for hard problem, and you know the constant. It will not pass. It will not pass the brute force approach. So because why it will not pass? The maximum length can be 5 into 10 to the power 3. So this will be 5 into 10 to the power 3. For each case, you are like for one, you have to iterating 5 into 10 to the power 3, and second one you have to iterate for 5 into 10 to the power 3. Okay, so So it will be 5 into 10 to the power 3 into 5 into 10 to the power 3 times you are going to iterate. So it is nothing but very high time complexity. Okay. So what I mean by that, maximum character is 10 to the power 4 and it is 5 into 10 to the power 3. So let's say my character present is 10 to the 10 square. Okay. Why I'm saying 10 square you can understand, because 10 square, like let's say my character present 10 square. Okay. And 10 square means like 10 to the 100, and each character is nothing but 5 into 10 to the power 3 length. That means 100. So it will be actually following this constant. So total number of characters could be 5 into 10 to the power 3 into 10, 100 square, that is 5 into 10 to the power 5, right? This is inside my constant. Okay. So that's why I'm saying like each word is length of this and my number of words of this. So for single word I am checking this many times. For second word I am checking this many times. So it is kind of we have to do the single comparison, like this is comparing or not. Then I have to check this is comparing, this is matching or not. This is how we could check. So it could create the TLE. It could create the TLE. Okay, so that's why it is not a optimal approach. Like we cannot take each and every pair and compare. So compare each and every pair is taking 100 into 100 time. So it is 100 into 100 time. Okay, so each and every pair it is taking time. Now again, each time I have to compare 5 into 10 to the power 3 comparison to check whether the strings are matching or not. In the worst case, I am saying. So it will be 10 to the power 4 into 5 into 10 to the power 3. That is 5 into 10 to the power 7. So you can think like if it is exceeding 10 to the power 6, then it will give the time complexity. That's why they have kind of forcefully made this two constant. So it will be 10 to the power 6. If you are exceeding 10 to the power 6, then it will be a problem. So brute force cannot be a solution. Hope you understand. So what could be the solution? Let's see. So in this case, what we could do, this kind of whenever we get the suffix problem, then we get what could be our solution, what kind of data structure we could use. In this case, if a problem based approach is build a try. So if I will match two try and we will can figure it out like whether it is matching or not. So what could we do if we build a try on this, and whatever the tries we get, and we get anything from here, then it will be a, like if it is match from the try, it will be a good thing. Like if we get let me give you an example and let's explain, it will be much easier. So let's say it is um, PBC, not PCA, uh, okay, and let's say BCA. Okay, so this is my word count and this is my what I'm not including this one. So let's build a try based on this thing. So how could we solve? Let's see how could we use a try to solve this problem. So if I take the first word, now it is I have to find out the longest suffix. So obviously I have to iterate from right to left. I have to iterate from right to left. I can't iterate from left to right. Okay. So what we could do, we could build like right to left. So we can build fast is D. So my try is initially, obviously my try is empty, nothing is there. Try is nothing but a tree you can think. So I can do what I have to do. D is not there, so I'll add a D. So after that C. Now I have to check is there any child of D is there? No child of D is there. So I can do what? I can do directly. C wants to be child of D, so I am adding the C. So after that, B is there. So I have to now check is B is child of C or not. So I am checking B is not child of C, so B will be here. So after that, I have to check A is child of B or not. So there is no child present of B, A, so I have to put A here. correct? Okay. Now see what is the in this case. Now again the same try I'll use. But so D is already present, so no need to add D. So I will check next thing, that is nothing but C. Now I'm going to check whether C is present in the D or not. If it is not present, add it. It is already there, so no need to problem. No need to add anything. Now I have to check K. Now K should be the child of C. Now is K child of C? No, right? So I will add K here. I will add K here. So K must be the child of C. Okay, fine. Now I will check what? I will check. Okay, let's take here also an example for this. Let's say XCD. Okay, earlier what is being taken actually. Okay, now again here D is coming. D is there. I'm not going to add. C I'm checking. C is already there. Not going to add. B I'm checking. B is already there. B I'm not going to add. Then X. X is a child of B. No, X is not a child of B. So I have to add X in the child of B. Okay, so this is what I am getting. After that, I am getting a new character, that is A. A is there in the try. This is my try, outer try. If the A is there in the try, no A is not there. So add A into the as a key. After that, is C is present in the part of A? No. So add C here. Then is P is part of A? No. So add P here. P is part of A. Then I am coming here. A is already there. No need to add. C is already part of A. So no need to add. Now B. B is nothing but I have to add B into the try. So I have to add B here. Try is a part of because B is not part of C. So I'm going to add that thing. Fine then. Now I have to check. Now I have to check each and every case in what query. See, this is the whole combination. Try gives you the whole combination from here. From starting from D, C, B, A. This is one letter from right to left. Then DCBX. So you can see it's another letter DCBX. Then DCK. DCK is another word, isn't it? So this is the what try helps you. Try helps you to find a kind of thing like I can see like there could be some cases are common. There could be some cases are common. So whenever I'm comparing with any case, if let's say these two cases are common, these two cases are common. So when I am comparing this CD with these two cases, so if I compare here and the meantime I can compare here, in the meantime I can compare here. So this is what I am doing. So that's what I'm doing. After that, I'm comparing this C, then C, then C. So its comparison is done already. If I compare any one case, I have already comparing actually in three cases, not only one case. I'm comparing three cases. Especially take this example. Up to D, whenever it is D, I'm comparing three cases. These three cases. When I am comparing after that C, so then I am comparing again three cases. Then see here, whenever I got B, then this index is out of case, out of my range because B is not present in the part of C. So in this case B is not present. So whenever I got B, so whenever I check this after the letter of the what is present in the before C, what is later before present before C, I can see like what are the possible conditions, what are the possible cases, and we can get in big of one time because we can use dictionary to build this kind of thing. So it is a big of one time thing. Okay, so we can directly see, we don't need to check like whether B is present or not or something is present or not. Okay, so again when I'm going to B, I can get like this is the B. This is the B is present, so I'll go to B. Now I'm checking for P. Now I have to check whether is a part of B in my parent array. So this is nothing but my parent array. So in my parent array is anywhere P is appeared before B. Like not only B, just P is appeared before this kind of sequence has arrived. Is P is a part of before that. I can say like this kind of sequences arrive twice. You can see D, C, B. This is the sequence it has arrived. Now, what are the cases? What are the letters that appeared before this kind of sequence? So you can see that only A and X is a part of that. Only A and X is a part of that, not the P. I can simply discard it. I can say this is the third, my longest common suffix. I can simply get it. Similarly, whenever XYZ I am getting XYZ, you can get XYZ is nothing but you can see Z. Z is not part of anything. Z is not part of anything. So this is nothing but my empty case. So if it is that Z is not present at all, my fast letter itself is not present at all, so then it will not create any problem. It will, I will simply say it is not present. So what I have to return, I have to return the index position of smallest word, index position of the smallest word I can return. Okay. After that, what we could do? After that, I am getting at the XCD case. XCD case, what I am saying, D is a part of that. So I can say again, D is a part of three words. So I can single time I'm comparing with the three letters. I'm not individually coming here and checking it whether D is a part of it, whether D is a part of that or not. I can single iteration I can check and say like it's a part of it now. And then I'm getting C. C is a part of. Is there any in a all the words present in that word container? Is there any C present in the previous this sequence? Yes, C is present in the sequence. In three sequence it is present. So it is there. I am adding that. I am checking C is there. Already C is a part of his child, so that means C is present. I am checking whether X is present or not. Wherever the sequence is CD, is X is present before the CD? Is there any cases? Can I see that? So this is the sequence of CD. So is there any child? Is there any child of C that is it is X, so that I can say it is present? No, there is no child of X. No child. So no child of C of is X. So it is B and K only. So they are only B and K. So X is not part of that. So that means what is the common? Common is nothing but C and D. Okay. This is how we have to solve. So this is how we do the string comparison. Okay. Now string comparison is done. Now what we have to notice, now we have to not only sending the length. If they ask what is this longest common substitution length, then it will be easy. Then it will be easy. Just see like how many letters we have traversed. Then we can send the letter. That will count. But they have asked the index position. Now the here the things gets complicated and here the things becomes hard. See here, this D is present here, this C is present here, this B is present here. This B is present here, this C is also present there. So when should I take which one? Like CD here present. So for this CD, so if CD is common, if any string for any kind of word CD is common, so then we should return 1. If BCD is common in for any string, you have to return 0. So you can see for each and every character, the string answer could be different. So what we will do? We will do what? We will check like whenever we start creating, when we start insert, so not creating, start inserting the each letter of the word, we will simply take that index. Like it will not only store, one is child, it will also store corresponding one value also. So let's store the value as well. Okay. So how could we store the value and how could we understand? Okay. So if I rewrite this thing, DC, so it's giving some space actually. So D, then it has two case. C, it could be, it is only one. D, C, it has two cases. C could be, after that it could be K or it could be B. B has two cases, it could be A and it could be X as well. Okay. So now each thing will contain a value. So whenever we will adding the word, we will add corresponding value as showing the index. So what this, so index will mean like for which index got, from which index you are this D. Okay. So that we will store. Okay, that we will store. Then what? Let's say let's starting from here. So D is coming from first 0th index. When I am building the tree, so let's build a tree again. Then you will understand how could we store the index and corresponding index. So D first, but this D is nothing but a sequence. You can see it's a single letter is nothing but a sequence. So D is appearing. So I am adding D. So adding D here, and what is the corresponding index value I am getting right now? 0. So it is not there. So whenever it is not there, like I will check whenever the D or something is not present inside my root or inside my inside my letter, I will check if something is not present, then I will simply get like if it is not present, I am getting this for the first time, right? if I'm getting the for the first time, I'm putting that which index from which index I'm getting that sequence for the first time. So I will add that. So so if it is present, then what to do? Then we will see later. We will see later. First, I am getting adding d here because d not present. So I am getting adding d here. So what will be the kind of value of that? It will be 0 because I'm getting d from the 0th index. So it is not present, I'm getting d 0th index. C, next I'm going to add c. So is c present? Yeah, c not present, I'm going to add c. As I told, if it is not present, I will add in from which index I am getting. So I will give you 0 because I'm getting from 0th index. After that, I'm getting b. I am getting b. So b here I am getting, or you can write it here as well. So b I am getting. So b from where I am getting, b is also getting from 0th index. Fine. Then I am getting what? I am getting a. From a I am getting a also coming from 0th index. So as it is not part of this, I am getting the 0th index. Okay. Now see. Now see this thing. If I told you that if CD is thing, CD for CD is common for this one and this one. If that is the common, that is the common. So then what could be the, if this is the common thing, if this is the common thing, these two are common. So then this should be the answer. Why? Its length is smaller. So that means if D is appear, if D is appear again, so that means I told you that this D is nothing but not a single letter. It is a sequence. This C is nothing but not only C. This C means it's C and D. CD sequence. So that is I'm getting. So whatever this D, whenever I D or any sequence I am checking. So if I get sequence again, that means D is already present. That means sequence. The sequence is already present. That means now I have to update the index because it could have present that this index, this sequence may have the smaller length compared to the this sequence what we got earlier. So what is saying see again, say see again. If the sequence is same, if the sequence is same, I have to find the sequence as a suffix, right? If the sequence is same, I have to find the which in the what container, whichever having the smallest or what is our in the smallest length. We have to find that dot. So that's why if I am finding any sequence D that is already present in that my try or in the child or something, if it is already there, then what I am to going to say, like I have to say whether this current index length is smaller than and the what is present in that index. If that is smaller, I will update it. See here, D is present. So D is the sequence I got. So that is appeared earlier. Now I have to check. I am storing what is storing I am here, not actually the actual the output. I am storing is from which from where I am not I am getting this D or which place is minimum, or which place that is minimum for now. For now, this is the minimum. Minimum in the sense which place the length is minimum. Okay, this if that means this D this zero represent where in which place this D has appeared and that having the smallest length that actually this zero represent as it is the appearing first time. So this is the first time. So for now only this is having the only word and it is the smallest length. Now this d is appeared again. Now it is the length. Now I have to check this d is appeared. Now what is the length of this zeroth index? What is 4? What is the length of current index? What is 3? So if d is appeared, so which index I should prefer? Obviously one, only D. If it is only D, I should prefer only one. So I'll update. I have to check if D is present. Yes, it is present. Then I have to check what is the length it is storing. What is the index it is storing. So whatever the index present in that position in what container, I have to compare with the current what length of the current word. I have to compare whichever having the smallest. This D should store that case. Should store that position because as I told, if only D I have to match, then obviously this is my best choice because this length is small. So that's why I'll update D as one first index. Then I will check what C. This C. C is present inside D. Yes, C is present inside D. So what could be the case? So then that means the C and D sequence appeared. If that is the case, again I have to see. Like if CD is the case, what could be the my best choice? Best choice nothing but this KCD. So again I have to check whether the length of this CD comparing to the length of KCD. So that means what the index it is storing here. I have to compare with that length. And if it is like what if my current length is smaller than previous length, then I will update. So this 0 will updated by 1. Fine. Now after that I will get what? I will get k. If k is the case, I'll get k. K is not part of the C. K is not child of the C. I will just add that into the child k and update its current index. That is nothing but 1. Okay, that's done. Now again D. Next, in coming the next word, I am getting the D. So D is there. So D is there means D is I am getting D earlier. Getting D is present or not in my try. It is present. So that means I got the D. So this one represent what? I got the D earlier. In that index, I got my entire string is the smallest with the same sequence. Sequence D. So it will come D is there it present. So I'll check whether what is present in this index is it greater than my current what is the string present in this index in the WC is that string's length is greater than my current string's length, is it not? Because see the string present in the one having the length 3 and it is having the length of 4, so that's why I will not update anything. Then I will come see, it will come see, it will see it is present or not, it is up, it will say I will update. I will not update because the length present, the string present in the first index is smaller than compared to the length of present in the second index. Okay, then it is coming to B. Now see here, here B is there. Now B's index is what? 0. It is saying now this sequence is appeared and it is appeared from 0 and not 0. The in which strings, the strings in which it has this length has appeared, among those strings, 0th index string having the lowest overall length. So now B has appeared again. Now I have to check whether this the string present in the 0th index is greater than this one. So if it is not greater, actually equal to same. So if it is same, I will not update because as the question says, if the same thing is present, if something is common, then I have to take the first, whichever having appeared first. So that's why it is 0. I will not update. Then X is there. Now X is a part of B. No, X is not a part of B. So I'll have to add that X. I'm going to add that X with 0. Not 0. X will be, what is the length is? Length will be 2. Not length, index will be 2. Then next coming to the PCA. That A is present. No, A is not present. So add A. And the length will be what? 3. C present. No, C is not present. Add C. Length of what will the index? Index will be 3. Then what is I'm checking P. P present? No. P is also not present. So add P. Length will be also like not length. Index will be 3. Index will be 3. After that, coming here, this A present? Yes, A is present. Is that what is the index storing there? Is it in that the string present in that index is smaller or greater than my current string length? No, it is equal. I will not update. Similar for C. C is there, but this string has same length of this string, so I will not update. But B is present. B is not present at all. I will add B. I'll add B. I will store what is the thing I'm getting 4. 4th index I'm getting this pattern. Okay, now let's compare. Now let's see what we can compare. Now I have to compare one by one. So here C comes here. So I have to here also I have traversed from right to left because I have to compare. So D is present in my try, whole try. Yes, it is present. Correct, it is present. If it is present, then D will give us what? -1. Sorry, not 1. Sorry, D will say I'm getting for 1 index. Now it is not end. So again C is there. C is present in the case. Yes, C is present. Cool. If C is present, then it is 1 and it is end of the loop. So current. So I have to need a pointer first. So earlier pointer is here. Now I have to check outer loop. Now I have to check this D is present in the outer try or not. Is D present? Yes, D present. Now this pointer updated. Now pointer updated and comes here. Comes here. Now pointer. Now what I have to check? I have to check C. C is present or not. Yes, C is present. So if that is present, this pointer now updated and pointer comes to here. Comes to here. Now I have to say whether anything is present or nothing is there. So wherever the current pointer is, this current pointer points to one index, right? That will be my answer. So that's why this CD comes from 1. Okay. Hope you understand. This CD comes from 1. Let's follow. Check the next case. This CD. So I'm so again this CD is pointer is pointing outside. D is present in this pointer. Let's say outer case. Yes, D is present. The pointer comes to here. Pointer comes to here. Okay. So now what we'll do? Now what case uh, D is coming here. So D next C is there. C is a part of C. C is a part of D. Yes, C is a part of D. So pointer comes here. If then B is a part of C. Yes, B is a part of C. Pointer comes down. Pointer pointing here. Now P is a part of B. Is it? No, it is not part of B. So doesn't matter what how many character present after that. If it is not part of B, that means I of that kind of sequence has never appeared in my word count. So whatever which position I am there, I am on the base position. Okay, so I'll break the loop, and whatever I told you, whatever the current count, what are the pointer is storing right now, that pointer is storing also an index also. So that will be my answer for this one. 0 is the answer. Okay, that is the case. Now see one nice thing. So XYZ, Z is present is part of this case. No, Z is not at all present. If that is not, then I have to return the index that I have, nothing but 1. That is nothing but 1. So that's why I'll return 1. The index having the smallest length of the string that I am written. Now similarly XCD, if you do, you will get it is a part of what? CD and it will be part of 1 only, because CD is common. CD is common, and X is not common. So CD is common is part of only 1. So if you do D is present, then D comes here, then I have to check C is present or not. C is present, yes, C is present. So pointer comes here. Then I have to check whether X is present part of C. No, X is not part of C. So I have to stop. And what is the current pointer? It will return that answer. So it is nothing but 1. So this is what it should return. Okay. So am I written something? Okay. So this is how we have to solve the problem. Hope you get the thing. Okay. So here right now you can use two things. You can use a different class to create this node, or you can use same map for that. I'm writing a class. Okay. So let's say creating a function. Inside the function, let's say I'm writing this name as find, whatever this is. And what is given? What container, what query. Okay, first I have to do what? First I have to check, like I have to create the class first. Let's create the class. Let's say class or type def, whatever you want. Is nothing but a node. Okay. So here what I need one integer variable, integer, that is nothing but my class variable. So it will point my index. So it will be index. Initial it will store -1, nothing. Okay. And what are other things it could store? It will may store child as well, child, and it is nothing but an empty map, because no child is present right now, right? So this is empty map. So this is my simple class. So this is my child. Class is done. So now let's see what are the things we could do. Now I have to build the try. So building the try, we need what? I have to iterate each and every case, each and every word. Okay. So each and every word I have to iterate, and let's see like whether it is present or not. So I need one what? I need one root from where I can store it. So I'm writing the root. Root will be nothing but a node, empty node. So root is nothing but node. Okay, this is my node. Then I have to, what I said, I have to iterate each and every word of this word counter, and I have to add into the try. So also I need to add the corresponding index position as well. So I'm iterating for each and every length, index by index. So for I starting from 0, then I less or equal less than word count, word container dot length, then I plus plus, simple. And after that, what I have to do, word container dot length, then I plus plus, then I have to finding the word and need see what I have to actually reverse the word. I have to actually reverse the word. Okay, so that's why I'm reversing the word. I have to reverse it. So word will be nothing but what is present in that index position, word container of I dot reverse. Just reverse the word. Okay, and I am storing the length as well. N equals to nothing but length of that word. Word dot. Do you understand why I is doing that later? Okay, so I also need two variables. I will tell you why I need that. Otherwise, you will not understand. I will tell you later. So whatever I am saying right now, I have to now each word I am traversing. Now each character I have to traverse. So for each character, so for character in word, I have to traverse. I have to traverse. So as I told you, I have to check whether this character, current character, is present in the root or not. Okay, so for that I told you I need a pointer. So before traversing this, I need a pointer. I need a pointer to know like what is the current position of that. So pointer will be nothing but my, let's say, current pointer. This is my current. This is my pointer because see earlier it is point this node. Now I have to check whether one character is present in the outer try in the main root or not. Then I have to insert the root and next character I am to check. This is how we should do, right? So that's why I need a pointer, and this pointer is nothing but my root. This is nothing but my node. So each character I am checking. So I am checking whether character is present or not. If not present, so if not, what is the thing? Current dot child dot finding what my current character. If it is not present, that means that this kind of sequence or this letter is not appeared earlier. So I simply create the thing. So I'll simply create, so current dot child of this character is nothing but my new node. Okay, and after that I told you if it is the first time I am doing the indexing, I have to say that index from which index I got this thing. So current dot child current dot child of character, then dot index equals to my current index is nothing but I, that I have to store it. Okay, now what are the things if it is present? If it is the case, if it is not present, it is case else. What if it is present? Then I have to check what is the length. Is the length like what is the length present in there, and is it that means like if it is present, that means this thing is already present and it is storing some length. Okay, some index. So in that I have to check if that index, if it is present, the index what is present, that string present in an index is that string's length is smaller than my current word string length. That I have to compare, right? That's why I'm checking this. If that is the case, what is the string present in that thing? So how could I find it out? String will be, that is nothing but where I'm checking wc, where current dot child of character. In this index, it is dot index idx. This is storing on index. So whatever this storing in this index, I have to check whether in this position is there any whatever the string present. If it is actually greater than my current length, that is nothing but n. Okay, so this is nothing but my size. If it is greater than my n, then I will redefine that index position. If that is the case, I'll redefine. So it will be current dot child of my that character dot index will be redefined by that I. Okay. And here my else loop also done. So now what will be my current? Current I have to update my current equals to current of that child, because see why I am doing that. So I have to update that current equals to current dot what child of what child of that character, because see this loops end here and this loops also ends here. Okay, so let's see why it is needed. Why it is needed? See here, right now, first I am to point to D. So D I am checking whether it is present in here or not. So D is not present. That's why I created in the outer case. Outer is also a node. So in outer case, I am creating a child, that is D. Now D is also one node, actually one node class, node data type. Now if it is now D is done, whatever I'm doing assignation, whatever they're doing, I'm done. After that, now next I have to insert C. So C should be inserted into the D8 place, not in the outer place. So that's why this current should point this side. So that's why in every word, whenever I'm starting uh, the word, that time current is pointing the outer root, and after every cases I have to inserting, like I have to change the current to its next position. Okay. Simple, I guess. Okay, you get it. Now let's see another case. So the case is like forget about the case. The case, forget about the case. Think of it is prepared. If it is prepared, so it is this thing is done. This is how we build a try. This is a building the try. Now the thing arises like kind of this case XYZ. If XYZ is not case, if not is the present. So this is nothing but this thing is nothing but a node, right? This is nothing but a node class. That means it also having some index. It also having some index variable, correct? So if it is also having the index variable, that means what? That means if say like if nothing is present, so nothing is present. So whenever we are checking, if not, let's say this, whenever we're checking this case, like whatever is XCD. So XCD, I'm checking CD is there. Now I'm checking X. So whenever X is not present inside there, where I'm returning, where is my current is there. So current cases. So similarly, if you see in the upper example, so this is nothing but another node. So this thing is point from another thing. So some empty space it is pointing from. So I'm checking here. So this is nothing but this outer node. So I'm checking whether D is present inside the outer node. So similarly, I'm checking if Z is present in the, like how I'm checking if this X is present inside the C or not. Similarly, I'm checking if Z is present inside the outer case or not. If it is not present, then it should return something. So in that case, I will say what should I return? The smallest character. So this outer node can contain the smallest case, smallest length that I can return. Understood what we are getting? Understand, like if the outer node could consider the smallest case, outer node consider the smallest smallest like index position having the smallest length of word. Outer node can contain that. If it is that the case, if that is the case, then what could we do? We could, if I got something and it is not present in the like main root, that means that entire thing, like this character not has at all appeared in my parent case, in my parent. At that time I will simply return what is the what is the index position having the smallest string. So that's why my root will store the smallest index position. So how could I find the smallest? Again, I have to iterate for each and every case and find the smallest case, smallest index position. Correct. So I'm already doing this iteration only one time here. What count? Do I have to iterate again? No need. I can create two variables and find the smallest. Okay. So that need this is basic problem how to find the smallest string in the string of list of strings. How could we do that? I will initialize two more variables. First one will be my, let's say, min length. Min length. I will initialize with what? Maximum value infinity and until the min length index. Index where the min length present. Min length idx. It will be nothing. You can put -1 anything. You can zero anything. This is fine. So where I will check here inside here, when I am finding the length actually, I will check on another step as well. I will check another case as well. Let's put these things after this checking. Okay. I will check if this what is the size is less than my min length, then I will update the min length index. So I will check if what is the min length? This min length will show my current min length. What are the fine min length is kind of infinity. That's why it is infinity my current. So what is the if n is less than my current minimum length? If that is the case, I will update. I will update what? My current minimum length will be min length will be my n and minimum length. What is the index? This length index will be my I current index, and the very end at the end of the things I will simply assign that root has some index. So because root is just a type of node, so root of index it will find that thing min length index. Min length index. The root of this will contain this. Okay. Hope everybody got this thing. It's a very long function actually. Cannot minimize. If I minimize, it will be too small. Okay. This is, I guess you can see. Okay, this is my still now this thing. Now after this, I am writing this thing in here in this place. After the checking, I need to return something, right? I need to check what are the matching cases I have to check, right? For that case, I need what? I need one case. Another thing, I need one answer array or vector list. So this is nothing but an empty list. Okay, and this is nothing but an empty list. Now I have to iterate. Answer is nothing but my empty list. Now I have to iterate each and every word present in my queue list. Okay. So right now no need for index, so that's why I will do normal iteration. So for each word present in my word queries, I am iterating through it. Simple as always. I need to reverse it. So word I have to reverse. So word will be word dot reverse. Okay, I'm reversing this. After that, what I have to do, I have to iterate for each and every pointer, each and every case, and also I need what? My current will should point my root node, my root. Okay, now I have to iterate for each and every case. So for each word, for character present in this word, I am iterating. So I will check if it is present. I'll not do anything. I will just going forward. So let's say like for this example, that D is present or not. If D is present, I'll point this index to D. I'll not anything. If nothing is present, I'll break the loop. Like for X, this XCD, D is present and pointing D. When C is present, then I'm pointing the character in C. When X is present, X is not present. I will break the loop. A simple I have to check if it is not present. If it is not present, I will break the loop. So I'll check if not present. So not where it is not present. My current dot child. If it is not present in current dot child, it's a finding my character. If it is not present, that time I will break the loop. I will break the loop. So simple I'm writing break. If it is not break, that means I have to, if it is present, then otherwise it will present. In that current will be current dot child of that character. I am pointing that thing simple. That's all. So then I am closing this. At the end, what it is there, it will return answer dot append. What it will append nothing but my uh, current, whatever I am present, the current is there, so it is current index. Okay, so current dot idx will append that. So what if it is outside, like xyz, g is not present in the node, so that's why I am storing that node index is something the minimum length index. So that time it will return only root node index. Root node index. That's why it will work. So I will say that time this is done and this is case and return my answer array. Then the loops is also done. Then my loop is also done. Okay. So let's see let's see the time complexity and space complexity of this problem. So time complexity is nothing but I am iterating for iterating my each character, each string, and for each string I am iterating for each character. That is my time complexity. Here also each word I am iterating and each word I am running each character. That is the time complexity. What is the case at most time complexity is nothing but it is the question in the given question it is mentioned. It will be this 500 into the power 5. So at most that means I am iterating maximum every character of that. I am iterating every character from that given array. That is what is the maximum line is 500 into the power 5. The time complexity is at most 500 into the power 5 as I am iterating each and every cases. Okay. So what will be the space complexity? Space complexity also, like I am storing every character in this case, Assume what is the pattern is given, every pattern is unique, entire pattern is unique. So entire pattern I have to store that each and every character in this string, it will be larger and larger. So it will be storing entire pattern. Okay. So in this case, so time complexity is nothing but here the total number of character present. Total number of character present. Actually, maximum of total number of character present in WC and WQ. Okay, this is the thing. And for space complexity, it will be the same. Maximum, like total. Here it is total number of character present in number of character present in WC, especially because I'm storing building type based on WC. WC means word container. Present in WC. Okay, so for better writing, you should have written this one. This is the space complexity for sure. Present total number of characters. I will understand total number of characters in WC, and same thing in WQ. Word of query. Present in WQ. WQ, and I need the maximum of that. Whatever having the maximum. That is my time complexity. Space complexity is this one. Hope you understand the problem. This is the way. Another way you can do this problem in a different way, that is nothing but you can reverse the array. Then you have to find the longest common prefix, not longest common suffix. So if you reverse it, and you will get the longest common prefix, not the suffix. And you can solve the problem in that case. Okay. As always, if you find any mistake in this video, please let me know so that I can rectify. And if you find any useful information on this topic, please also let me know so I can also learn. Take care. Bye bye.